All right, welcome to video 3. We're going to be talking about even and odd functions. We're taking a little bit of a break, from these transformations and talk about something related, okay? Also, have some adorable cats, or at least parts of them. All right, so for even and odd functions, essentially, we've already talked about what it is that they are, right? So let's kind of go back to this. So remember when I said, okay, let's say we have x cubed. No, actually, we use the cubed root of x. Cubed root of x, again, is the same thing as x to the 1/3. And I said, well, let's look at x to the 1/3 with a vertical reflection. If we reflect that blue graph upside down, you get the orange graph. But I said you might also have said, isn't this the same thing as reflecting the blue graph left to right? The answer is yes. Right? Whether I do it on the outside of the function here or the inside of the function, it's the same thing. Similarly, if I looked at x cubed, if I reflect this on the outside, that's flipping it upside down. But maybe you say, well, this doesn't look like upside down to me. Now I'm moving the negative to the inside. That's moving it left to right. Maybe you see it this way. They're both equivalent here. This is going to sort of lead towards what we call odd functions. It's not a coincidence that the exponent is odd. Okay? Specifically, odd functions are functions where if I reflect it horizontally, like I've already done, and then reflect it vertically after that, we get back to the original function. Okay? Look at another. Whoa, that looks weird to see at the same time. Let's look at another one. If I reflect it about the x-axis upside down, and then reflect it around the y-axis left to right, we are back to where we started. And again, this negative on the outside is a vertical reflection reflecting about the x-axis. The negative on the inside is a horizontal reflection reflecting around the y-axis. I'm hitting myself in the face. Okay? So that's the idea of an odd function. Let's write that down. Okay? So, definition. F is odd if reflecting it about both axes. Ooh, I didn't give myself enough room. So this is reflecting it about both axes, right? Negative on the outside and negative on the inside equals the original function. And again, we just saw a couple of examples of it right here. Reciprocal function, reflect it on both axes, and notice how both graphs are the same. Okay? Similarly, f is even if reflecting it only around one of them is equal to the same function, and specifically reflecting about the y-axis. Side note. Well, I won't make the side note, okay? So it's even if reflecting it around the y-axis, a horizontal reflection makes it the same thing. So notice, if I have x squared, if I put a negative on the outside of the function, that flips it upside down. But if I put a negative on the inside, that flips it around the x-axis. Right? Reflecting this around the y-axis. Reflecting this around the y-axis doesn't do anything. It's symmetric. Okay? It's a symmetric function. Another way to think about this is if I add a negative here, when we square it, the negative squares away. Okay? And another even function we had here is the reciprocal squared function. I don't know what I'm writing there. And again, just very, very similar, and for very, very similar reasons, right? If we reflect this about the y-axis, that's adding a negative on the inside, horizontal reflection. The orange and blue graphs are the same. All right. One more even function that we have here in our toolkit arsenal is the absolute value of x. Ooh, not that. Thank you. By the absolute value of x, and I reflect that again, about the y-axis, it's the same exact thing. Symmetric, right here. Same on the right as it is on the left. Technically, we have another toolkit function that's even, but this seems really kind of silly to say. This is an even function. It is the same to the left as the right. It's a constant function. Anyway, that's true as well. And there's another odd function with the identity function. Those are kind of the big ones. Okay. So let's talk about how to find whether something is even or odd. All right. Let's do example. Oh, I've lost my paper. Example F, right? Who knows what number on? We're on letters now. All right, example F. Are the following? F is maybe a bad choice to choose when you're teaching a class. Yes, F's everywhere. Are the following even, odd, or neither? And with numbers, right? 2, 5, 7. These are all either even or odd numbers. With functions, something can be neither even nor odd. Okay. Let's do part A. Part A is going to be something. Y equals x squared plus 2. Is this function even, odd, or neither? So we have to check. Okay. Check if it's even. So a function's even if reflecting it around the y-axis, a horizontal reflection, doesn't change it. So let's find things out. All right. What we're going to do is replace x with negative x and see if it's the same. Right? If this is the same, x and negative x, then it's the same thing. That's going to give us y is equal to negative x squared plus 2. Well, when we square that, that's y equals positive x squared plus 2. Oh, yeah. Same. All right. So these are the same, so this is even. Yes. It's even. And it is very, very rare, but technically possible that a function is even and odd. That's a very silly case, but we're just going to check. Let's show, is this odd or is this not odd? So one way to do odd is to replace x and y with negative x and negative y. See if it's the same. Okay, is negative y equal to negative x squared plus 2? Is negative y, again, that still squares away, x plus 2. Oh, this is not the same. Y cannot be x squared plus 2 and negative y equal to x squared plus 2. These are different functions. We could multiply both sides by a negative, right? Very different function. Okay, so it's not odd. So our final answer is this is only even. Let's look at a slightly different perspective of this problem. You can use this perspective to say whether it's even or odd. You can do a different one as well. But before we go on, actually, I do want to show this off, right? I told you this function, and hopefully I didn't lie to you. I told you this function, y equals x squared plus 2, is an even function. Oh, we're green now. Notice how this is an even function. It's symmetric with respect to this y-axis. All right. Let's look at another way of approaching these problems in part B. It's the same thing, but it's a little different. Okay, so let's look at f of x equals x plus 2 squared. And you might say, Jason, this is just a quadratic. It's going to be the same thing. All quadratics are even, aren't they? Let's see. Okay, so remember the definition. It's even if f of negative x is the same as f of x. So it's even if f of negative x equals f of x. That's our definition. So let's find out f of negative x. Is this going to be the same? So f of negative x is just the same thing, but replace all the x's with negative x's. But this isn't the same. Okay? You can't just square away the negative here because you can't just square things. You would have to FOIL this out and unfoil it. Okay? This is actually not the same. So it's not even. Okay? And it can be kind of hard to see this, but plugging in some points can show this, right? For example, if we wanted to find f of 2, plug in the point 2, that'd be 2 plus 2 squared, 4 squared, 16. But if I replace that with negative 2, that's going to be negative 2 plus 2, which is 0 squared. 0 squared is 0. And these are not the same. This should be the same for any number I plug in. F of 3 should be the same as f of negative 3 if it's even. F of 4 should be the same as f of negative 4 if it's even. All right? So that's another way to sort of check. So it's not even, but maybe it's odd. Probably not. Let's check. It's odd if negative f of negative x equals f of x. Really bad problem of just writing into pre-existing writing. Okay? So let's look at what is negative f of negative x. Well, that's negative on the outside of f of negative x. Like so. And again, there's a couple of ways of seeing why this is not the same thing. But this is also not the same as the original f. And again, we could look at, well, what is negative f of negative 2? If it's odd, this has to equal 16. By the definition, adding a negative on the inside and the outside has to have the same output if it's an odd function. If we find it, we've already found out that f of negative 2 is 0. If we negativize that, that's also still 0. Not the same as the original function, so it's not odd. So it's not even, it's not odd, well, it's neither. Okay. Do 2 more of these. All right, part C. Goodness, it's sun's going down. I don't usually record these so late. If I look at g of x equals x cubed plus x squared, let's check even. Remember, even if g of negative x equals g of positive x. So g of negative x, replace all those. Negative x cubed plus negative x squared, and we can simplify this a little bit. Negative x cubed is just negative x cubed, but when you square negative x, it becomes a positive x. Are these two things the same? No, they're not. One is a negative x cubed, one is a positive x cubed. Not equal to g of x. So not even. Check if it's odd. It's odd if negative g of negative x is equal to g of x. So what is negative g of negative x? Going to be negative on the outside and then negatives on the inside. And simplify this. Again, this is still negative x cubed. Again, this is still positive x squared. Deal with that negative, distribute it in. Negative times a negative is a positive. Positive x cubed, negative times a positive is a negative. Ah, this is also not the same thing. It's also not odd. Right? That's not equal to the original function. So again, this is another case where it's not even and it's not odd, neither. Let's do one more. Really work this down. Feel free to pause the video. I go kind of fast because I figure if you ever want a pause, you can just kind of pause it yourself and just stare at the screen. And hopefully I won't be making any weird faces when you pause. Okay? So if you ever want to pause, go ahead and pause. I'm going to keep on going though. For those that don't want to pause. All right? So get f of x equals 1 over x plus 2x. So again, it's even if f of negative x is the same thing as f of positive x. This is the definition of even that we wrote on the previous page. We're going to say, well, what is f of negative x? That's going to be 1 over negative x plus 2 times negative x. That's going to be, well, we can write that as negative 1 over x. All right, this is minus 2. Gosh darn it, Jason, this is not the same either. Nothing's even, nothing's odd. All right, it's not even because it's not the same. All right, this is not equal to our original, ooh, wrong letter. Not equal to our original function. And again, it's odd if negative f of negative x is equal to positive f of x. So again, let's calculate negative f of negative x. Again, it's going to be a negative on the outside. And then replace all the negatives on the inside. 1 over negative x. It's 2. It's negative x. Just like before, right? We already found out what f of negative x is. It's going to be negative times negative 1 over x minus 2x, just like before. But now we have a negative on the outside as well. Distribute that in. Positive 1 over x. Positive 2x. And thank goodness. Notice. These two things are the same. F of x was the same as negative f of negative x. Okay. That is equal to f of x. So it is finally odd. Great. Okay. That's even in odd functions. And again, if you were to plot this function, it should have that sort of double symmetry. Symmetry about the origin, we say. Y equals 1 over x plus 2x. What does that look like? Actually, it looks pretty bizarre. Look at this. Notice that if you do reflect this both ways, right? Reflect it one way, it looks like this, the white graph. Reflect it the other way. We reflect it both ways. We do see that the white graph is the same as the green graph. That's what it means for something to be an odd function. Symmetric about the origin. Every point here, you go to the opposite side of the origin, you should have another point down here. Right? That's even in odd functions.